Namaste and good morning. I'm your science teacher Lil Hamal. Well, we are going to talk about the last part of grade 9 science, the work, energy, and power. Today I'm going to terminate the power. If we've got some minutes left, and we'll be talking about some of the numerical problems. Basically, students are keen to learn to solve the numerical problems. Well, okay, let me welcome you in my class. This distance teaching program is brought by Metro PABSON Bharatpur and broadcasted by Kalika SD. Well, let me start my lesson today. So the power. So we did work, energy, and today I'm going to talk about power and its basic concept, and we'll go through some of the class activities. So my students, I'd like to ask you to get ready with a pen, paper, and calculator if you have. Thank you. Well, what is the power? The rate of doing work is called power. Okay? The rate of doing work is called power. It is the work divided by the time. It is the work divided by time. Okay, so but some of the cases, especially the devices, they actually do not work. For example, the electric bulb does not work, the TV does not work, but it converts one form of energy to another. So we can define power in that condition, the rate at which the device can convert one form of energy to another form of energy. Okay? For example, the rate at which an electric bulb can convert electrical energy into heat energy and light energy. Okay, that's a definition of power for the devices, for example. Well, and the power, its SI unit is joule per second. That is called watt. It's after the name of James Watt. And its CGS unit is the erg per second, because joule, the CGS unit of joule is erg, and second, the second, And the power, P equal to work done upon time taken, work done in joule unit, time taken in second unit, joule per second, is equal to the watt. Power actually depends upon two factors. Number one, work done, and number two, time taken. So power depends upon two factors, the work done and time taken. The power is directly proportional to work done, and power is inversely proportional to time taken. More the work done, more the power, and vice versa. It means less the work done, less the power. So basically, the time is limiting factor to describe about the power. If the time taken is the less, the power is the more. And if the time taken is more, the power is the less. So power is inversely proportional to the time taken. So P alpha 1 upon T. So that's a concept you need to know. Well, so let me share my screen. So have a look. So define power. Power can be defined the rate of doing work, or the rate of doing work is called power. For devices, power can be defined as the rate at which it can transform the one form of energy into another form is called power. It's a SI unit of the power. There is some spelling error. SI should be SI unit. The SI unit of the power is joule per second or watt, and CGS unit is erg per second. We talked about this. Power equal to work done upon time taken, or P equals to W upon T. The power depends upon two factors: work done and time taken. Next, power is directly proportional to the work done. It means more the work done, more the power, less the work done, less the power. And inversely proportional to time taken. Less the time taken, more the power, more the time taken, less the power. Less the time taken, more will be the power, and vice versa. Less the time taken, more will be the power, and vice versa. So you have a look here. Less the time taken, more will be the power, and vice versa. It means more the time taken, less will be the power. Okay, for example, two machines doing the same work can be of different power. How and why? Here is a question. Okay, so they are doing the same work and same amount of work. For example, let's talk about 100 joule work done by machine A, and again the 100 joule work done by the machine B. The same work, same quantity of the work. So yeah, and some people can say they have done the same work, so they should have the same power. Answer: no, because one of them may work slower in comparison to other. If the work done is the same, the power depends on time. Less the time taken, more will be the power. So the P is inversely proportional to the time taken. So less the time taken, more the power. So out of two machines that work faster has got more power, and that works slower that has got the less power. Okay, slower means taking more time. Okay. Okay, I think you understood. Two machines two machines doing the same work can have the different powers. Okay, so for example, machine A, machine B. Okay, so machine A took 10 seconds to do 100 joule work. Another machine took 20 seconds to do the same work, 100 joule work. So machine A took less time, so that it has got more power. So P equal to W upon T. So here 100 divided by 10 equal to 10 joule per second, or 10 watt. So here what happens here? So 100 divided by 20, so that's a joule, that's a second, joule and second, that's a 5 joule per second, or 10 watt, 5 watt. That's why more time, less power. So one machine taking more time to accomplish that work has got the less power. Another machine taking less time to accomplish that work has got more power. So I think you understood. Okay, so let's have a look at my slide. So I've got a question. What do you mean by 1 watt power? Okay, so what do you mean by 1 watt power? So we know that P equal to W upon T. If W means work done is 1 joule and time taken is 1 second, then power P equal to W upon T, that is 1 joule upon 1 second, or P equal to 1 joule per second. 1 joule per second is 1 watt. So you should remember, to get the value of 1 watt, that of the power, you need to think about 1 joule and 1 second. So 1 joule work should be completed in 1 second. Power is said to be 1 watt if 1 joule work is done in 1 second. Okay, let me say again. So you can say in any way, but you need to mention 1 joule and 1 second. So if 1 joule work is done in 1 second, then the power is 1 watt. This is correct. Okay, if time taken is 1 second and total work done is 1 joule, in that condition the power is called 1 watt. Done. Or what I gave you the note on the screen, power is said to be 1 watt. If 1 joule work is done in 1 second, it's called, no need to say it's called. So that's a 1 watt power. So okay, so probably you understood. So have a look to illustrate that one. 1 watt. What do you mean by 1 watt power? This is a very important question. 1 watt power. Have a look on the board. P equal to W upon T. Okay, let or if W equal to 1J, T equal to 1 second, P equal to 1J upon 1 second, 1 joule per second, 1 watt. We get 1 watt if total work done is 1 joule and total time taken is 1 second. That's why the power is said to be 1 watt if total work done is 1 joule in 1 second. So you need to mention 1 joule in 1 second. So that is 1 watt power. The power is 1 watt if total work done is 1 joule in 1 second. Okay, have a look at my screen. Another one. Okay, what do you mean by? So what do you mean by this statement? Okay, Kohinoor has a power 100 watt. Next, 60 watt written on electric bulb, 750 watt written on a heater, 250 watt written on TV. So I'm going to do 1 and 2, not exactly 1 and 2, the first and second, no number is given. So you understood the second one and easily understand the third one and fourth one, so no problem. Kohinoor has got the power 100 watt. Okay, what does it mean? So the first one, the Kohinoor has got the power 100 watt means, so let me do something on the board. So Kohinoor has got the power 100 watt. 100 watt is equal to 100 joule per second. 100 joule per second means 1 second. So it means that C can perform 100 joule work in 1 second. What do you mean by the statement Kohinoor has got the power 100 watt? It means that C can complete 100 joule work in 1 second. So I think you understood. Time taken 1 second, total work done 100 watt. So that is the meaning of 100 watt power of Kohinoor. Kohinoor can complete 100 joule work in 1 second. This is the meaning of that. So have a look at screen. The second question, 60 watt written on the electric bulb, 60 watt. So 60 watt. So similarly 60 watt can be written as 60 joule per second. So it means that the electric bulb can perform 60 joule work in 1 second in the same way what we said in the first statement. But the electric bulb does not work. To further work, the electric bulb should move. Electric bulb does not work. So the answer that we give, just like first example, as I mentioned in case of Kohinoor, is not applicable to electric bulb because electric bulb does not work. But electric bulb can convert one form of energy to another form of energy. Electric bulb converts electrical energy to heat energy and light energy. So what can we say that? So it means that electric bulb can convert 60 joule electrical energy into heat and light energy in 1 second, or in every second, or in each second. What do you mean by 60 watt written on electric bulb? It means that it can convert 60 joule electrical energy into heat and light energy. Likewise, in case of the heater, 750 watt means 700 joule per second. So it means that heater can convert 750 joule electrical energy into heat energy because heater produces the heat. Likewise, 250 watt written on TV. So TV converts electrical energy into light energy, sound energy, and heat energy. So we can say that TV can convert 250 joule electrical energy into heat energy, light energy, and sound energy in every second, in 1 second, or in each second. I think the concept is clear. Okay, have a look at the screen. The next one, some of the popular units of the power. Kilowatt. So what do you mean by kilowatt? So 1000 watt is equivalent to 1 kilowatt. 1000 watt. So this is the bigger unit of the power. Megawatt, again bigger one. So 1000 kilowatt is equal to 1 megawatt. It means 1000 into 1000, that is equal to 10 to the power 6 watt. So have a look. 1 kilowatt, kilo means always thousands, 1 into 1000 watt, it means 1000 watt. Another, the 1 megawatt means 1 multiplied by thousands, that converted into kilowatt, again 1000, again multiplied by 1000, that is converted into watt. So 1, 2, 3, 4, 5, 6 zeros, that's a watt. It means 1, 0, 10 to the power 6, 1, 2, 3, 4, 5, 6, that is the watt. So 1 megawatt equal to 10 to the power 6 watt. That's a calculation. That's a 10 to the power 6 watt or joule per second. Likewise, have a look at my screen, and there is one more bigger unit of the power that is called horsepower, HP. It is equivalent to 746 watt. So 1 HP equal to 746 watt. And B means nota bene, that is just like a note. Kilowatt and megawatt are bigger units of power. The power of the machine is popularly measured in HP, horsepower. Okay? The power of the machine is popularly measured in HP. For example, if you see the power of the car or bike or something, you will find its power in HP, like 3 HP, 4 HP. So HP means the power of 1 horse. Okay, traditionally, the people used to measure. Now we've got some of the activities. I would like to ask you to see the questions, and we'll be going one by one. A couple of them are easier, and if you don't know, so really I can't hear you. So I'll be giving the hint. Okay, write any two differences between work and power. I'm just talking about this. So make a table, the work in the first column, second column power, give the definitions. The product of force and displacement is called work. The rate of doing work is called power. SI unit of work is joule. SI unit of power is watt. So that's it. So that's cool. Okay, so you can give one more if you like. A machine does 1000 joule work in 10 seconds. Calculate its power. And have a look, question number 3 and question number 4. So now I'm cleaning the board, and I'll be back in 10 seconds. Likewise, question number 3. Well, question number 3 says, calculate the power of a man, mass 80 kg, if he can climb a staircase of height 10 meters in 5 seconds. Need to calculate the power. And I would like to ask you to make a screenshot or to take the picture of the questions so that you will calculate in leisure, taking the hints. So have a look on the board. Question number 1. No need to do question number 1. I start from question number 2. A machine does 1000 joule work. Work W equal to 1000 J time T equal to 10 seconds. Power P equal to watt. We know that this is the simplest one. P equal to W upon T, 1000 upon 1000. So the unit of power is, you can write joule per second or watt. Hence, the machine has got the power 100 watt. So this is the answer. Okay, let's talk about question number 3. Okay, question number 3. Calculate the power of a man, the mass 80 kg, if he can climb a staircase of height 10 meter in 5 seconds. So quickly write down question or just take a picture and let's think about that. So I just would like to give you the hint of question number 3. So what you do, you find out the P equal to W upon T. W equal to F into S. F into S if it is horizontal, but it is the height. That's why F into S upon T. Again, so I don't have direct value of F. So first and weight the same thing. That's why what I do, I write down mg in place of F. mgh upon T. Directly you can put the value, formula. So we know that P equal to mgh upon T. Now put the value here. So mass of man 80, g acceleration due to gravity 9.8, h height of the staircase 10 meter, and time 5 seconds. Whatever you get the answer, use calculator. That will be the answer in what? Okay, just use calculator, that'll be fine. Well, question number 4. So have a look, question number 4. Calculate the power of a crane if it can lift a load of 2,400 Newton to a height of 10 meter in 15 seconds. Also find the power in HP. First of all, find out the P, and then after convert that P in HP. So first of all, find out the P, power. The power can be converted into HP by dividing 746. Okay, so I'm doing very the shortcut way. So the calculate the power of crane if it can lift a load of loads. It is given already in a Newton. Means you can write load or force. Same thing, force. Load, same thing, 2,400 Newton. And height, h 10 meter, time t 15 seconds, and we know that P equal to W upon T, F into H upon T. F 240010 divided by 15. What do you think you get? So would you like to use calculator? So I'm using my mobile as a calculator. So 2400 into 10 divided by 15, 1600. So therefore P equal to 1600 watt. Answer. Again, to convert into HP, horsepower, question says find the value in HP. So this is the same. You can write HP as well, or P equal to 1600 and 746 HP. So divide 1600 by 746 because 1 HP equal to 746, 2.144 equal to 2.144 HP. Hence, the power of the machine in HP is 2.144. That's the answer. Well, says, have a look. We've got some of the class activities. This is your homework. I'll be doing one out of them. First of all, I would like to tell you the answer of question number 4. These are actually from the subunit energy. I didn't get enough time to recap this thing. That's why I brought here. Question number 4. Name the device that converts the energy as sound energy to electrical energy. Answer, microphone. Potential energy to kinetic energy. You can write catapult, you can write bow, you can write the water released from the pond or reservoir. That's it. Chemical energy to electrical energy. Dry cell, or simply you can write cell. Okay, CEL, cell. Okay, so it's about the one you use the Ke equal to 1 by 2 mv square, m equal to 2 kg, b equal to 20 meter per second, and you will easily find out the Ke. Brick of 5 kg is kept at the height of 50 mg. You calculate the PE equal to mgh, put the value of g 9.8 meter per second. That's fine, it's easier. Question number 1, use the formula Ke equal to 1 by 2 mv square. For the question number 2, use the formula PE equal to mgh. Keep on looking the question number 3. So I'll be doing quickly the question number 3 for you. Well, so question number 3 says, keeping the mass constant, the velocity of moving body is increased by 10 times, then by how many times the velocity will be increased by? Okay, so question number 3 I'm solving for you. Okay, let m be the mass, b be the velocity, then Ke equal to 1 by 2 mv square. Ke equal to 1 by 2 mv square. Okay, so according to the question, in the beginning the mass was the m, the velocity was b. Now kinetic energy 1 by 2 mv square. So according to question, what question says? Question says the velocity is increased by 10 times, keeping the mass constant. Mass m is made m. If it is made double, would be 2m, triple 3m. But the question says mass is kept the same. You can write equal to if it is equal, And velocity is made 10 times greater. It means b becomes 10b. Then Ke, this is the Ke, new Ke dash 1 by 2, m is m and b is 10b whole square. Okay, so have a look here. Or Ke dash equal to 1 by 2 m, 10 whole square means 100 mv square. So b square, not mv square at the moment, b square only. So b square. So it's where did you get the 100 from? 10 into 10, 100. Or Ke dash equal to, so 100, please bring at the front, 1 by 2 mb square. This 1 by 2 mb square is equal to Ke. From where? From equation 1. Ke equal to 1 by 2 mb square. So Ke dash means new Ke becomes 100 times greater than that of its original value. Hence, the Ke will be increased by 100 times. That's all. Have a look. So I think you understood. Says the Ke equal to 1 by 2 mv square. The mass is the constant and velocity is made 10 times. Ke dash means Ke new 1 by 2 mm, but b is made 10b. That's why whole square. Ke dash equal to 1 by 2 m, 100 b square. Ke dash equal to 100, bring at the front. 100, 1 by 2 mb square. 1 by 2 mb square is equal to ke, so 100 ke. Hence, the ke will be increased by 100 times. So that's all. So the rest of the questions I would like to give you as a homework, and have a good time. Well, see you next time. I would like to wish you a happy Dasai. Thank you. Have a good day. Bye.